Okay, so at the end of class last Wednesday, I said I'd make a video showing the small calculator and how to find the expected value and standard deviation of a discrete probability distribution. So we're going to use this example here. This is on page 89 of the notes, where we're looking at the number of red lights that woman hit to work, and we have all these probabilities for how many lights she might hit. So again, this is a valid distribution because all of my probabilities are valid probabilities. They're between 0 and 1. And if I were to add all of these up, they sum up to 100% or to 1, which is showing that I have the entire sample space. So how I can do the expected value and standard deviation. We obviously have the formulas on the previous page, but it's a lot simpler to just do this with a calculator. So let me show you how that looks. So first thing in either calculator, I need to put in a list with all the different values she could hit. I have a lot of weird math stuff going on in terms of number of lights she could hit on the way to work. So I'm going to go into where my lists live. So in the big calculator, I pressed stat and then I chose edit. So I have stat and edit. For the little calculator, I'm going to hit data. You can see both these calculators already have values input into my L1. So for the big calculator, I'm going to go up, highlight L1 and press clear. And for the little calculator, I'm just going to hit data again and tell it to clear out L1. I'm actually going to need both lists because I need a list for the probabilities. So I'm also going to clear out L2 in my big calculator. And then we're just going to put down all the different amounts of lights she could hit on the way to work. So that was 0 to 5 were the different answers. And I'll do that on both of these calculators. So if I were to just do one var stats on this alone, I'm going to get the average for the numbers 0 through 5. And it doesn't take into account the fact that she's more likely to hit 2 lights and very less likely to hit, she's less likely to hit the 0 or 5 lights, right? Those are more unusual. So we could look, let's see. I need to tell these things how often they happen. So that's what I'm going to use for L2. So I'm going to go to L2. Unfortunately, I don't remember these. Let me just look. 5, 25, 35. So 0.05, 0.25, 0.35. Then it was 0.15, 0.15, and 0.05. And I'll do the same thing in the little calculator. I'm just going to enter all those probabilities in a row. Sorry, it like shakes my whole camera setup because I'm working on top of this bed in the back room on a piece of cardboard. So, okay, once we got everything in, we do have the values of the number of lights she could hit along with the corresponding probability. We're basically going to have our calculator do this weighted mean. So in the big calculator, we're going stat and calculate. Little calculator, we need to press the second button to get to stat and calculate. And we're just doing one variable. That's all we have, the number of lights she'll hit. So we're doing one variable, statistics. Now for the little calculator, it asks me where's the data. So this is where the actual variable is, which was in L1. And where is the frequency of this? And since we have probabilities, those are basically how frequently this would happen in a long run sense. So I'm going to change that to L2. Now my big calculator, if you have the stats wizard, it looks pretty similar to little calculator. I don't have a stats wizard on this calculator. So I'm going to do L1. Use the comma button, which is above 7. And then to get the L's, by the way, you're not going to use the alpha key. L1, L2, L3, they're all right above the numbers here. So I'm just going to press second and then number 2 to get L2. So L1, comma, L2 on the big calculator. And if you do either of these, you can see it. The one check you want to make sure that you haven't done anything wrong here is your N should equal 1. That's the sample size. Essentially, it's telling you it summed up all those probabilities and got at ones. You can see on both calculators I did that correctly. And then my expected value or my mean is 2.25. That makes sense if we consider the fact that 2 was the most likely thing to happen. And there was a little bit more weighting in terms of this 3, 4, and 5. There's a little bit more probability on that side. So it got pulled a little bit above that too. And then if we scroll down, we don't have a sample standard deviation because that would require us dividing by 0, and -1 would be 0. But we're going to use the population standard deviation because we're using the true values, the true probabilities, not a observation of what happened for this woman. So That's how you find your expected value and your standard deviation when dealing with a discrete probability distribution.